Hello students, welcome back to your class on file system. Last class we had discussed about your file system implementation. So what is the data structure that is required in the memory to support the file system structure? We had also addressed to your virtual file system, and then how do we implement the directory structure, what are the methods to implement your directory structure, and then to the end we had started with your allocation methods. So there are three allocation methods: contiguous, linked allocation and index allocation. Last class we had addressed to your contiguous allocation. We saw how contiguous allocation is done, what are the advantages and what are the disadvantages that is associated. So contiguous allocation on a disk, it needs a continuous set of blocks to be allocated which suffered from external fragmentation. Now let us see the other methods that is there. So the next one we have is the linked allocation. So linked allocation solves the problem of your contiguous allocation, that is majorly having a set of blocks together. So here each file is a linked list of disk blocks. The blocks is scattered all through the disk. Now here there is no more a restriction that we have, that we need a continuous set of blocks to allocate a file. So the blocks can be scattered anywhere in the disk, and there will be a link that would be attached to the disk. So what is the directory structure contain? It contains the file name, the starting and the ending block of the file. You can see here we have a file named Jeep and the starting location is 9. And you can see here there are around 5 blocks that is allocated. So starting with block number 9, and now this block number 9 is leading to block number 16, and block number 16 is leading to block number 1. Block number 1 is leading to block number 10, and block number 10 is leading to block number 25. And here the -1 indicates the end of file. So here we have the information only about the first and the last block. So from the first block we traverse to various other blocks that makes up the file. So let us see how the creation and read write happens. So to create a new file, we simply create an entry in the directory. With the linked allocation, each directory entry has a pointer to the first disk block of the file. This pointer is initialized to nil to indicate that it is an empty file. So when the file is just created, it does not have any data, it shall be indicated by nil, indicating it is an empty file. Then if you want to perform a write operation, so the write operation here, it uses the free space management. Probably that is the next concept that we will be addressing to. So the free space management finds a free block, and this new block is written, and that will now be getting attached to the end of the file. Now if my end of file is block 25, for example, I have to write a new data to block 20. So I will be linking again from 25 to 20. And read operation is a traversal that happens from block to block. That is, if you want to read a file, we simply read the blocks by following the pointer. And it is quite evident that there is no external fragmentation. Having said that, to address to some of the advantages and disadvantages with the linked list, with the linked allocation. The advantages, it's very flexible in terms of the file size. The file size can be easily incremented. This was not the case with your contiguous storage or your contiguous allocation. If the file size is too large, it is very difficult to find continuous allocation of that large space. So that is no more an issue, and that turns out to be an advantage here. And as told many a times, it also does not suffer from external fragmentation, which was an issue in your previous method. Now, what could be the disadvantage in case of your linked allocation? You can notice here, I cannot randomly access the data block. That is, I could do that in the previous method, but not here. In a file, if I am interested in a particular part of the file, let me say I want to access block number 10. Probably it is not possible due to the linked fashion that it has. That is, if I have to access block number 10, I will have to make the traversal from block number 9 to 16 to 1, and only then I am able to access block number 10. It does not support random access or direct access. The other disadvantage is the pointer that is required. You already know the concept of your pointers. So this can be an overhead in processing. So these are some of the disadvantages that is associated with the linked allocation. Now let us see to the file allocation table. So a section of disk at the beginning of each volume is set aside to contain this table. The table has one entry for each disk block and is indexed by the block numbers. We just saw an illustration here. The actual implementation would look something like this. So the file allocation table is used as the same way as the linked list that you worked in your data structure. So the directory contains the first block number, and then the chain continues until the last block. You can see an example here. We have the starting block that is 217. Now when I go to 217, that will direct me to 618, and when I go to 618, it directs me to 339. So this is a small glimpse. The other issue that we can notice here is if one of this block or the link is corrupted or lost, it will probably lose the whole of the file. That is, now if I just miss out this link, I would not know where is it next heading to. This is also the other issue that is related to the file allocation table. The next thing and the last method that we have is the indexed allocation. So in the previous method, each block was giving the address or was linking it to the next block. Here we put all the pointers together into a single location or a single block, and that block is called as the index block. Now each file that is created would have its own index block, which would be an array of disk block addresses. The ith entry in the index block points to the ith block of the file. The directory address contains the address of the index block only. And if we want to find and read the ith block, we use the pointer in the ith index block entry. When the file is created, all the pointers of the index block is initially set to nil. When the ith block is first written, a block is obtained from this free space manager and its address is put in the ith block index entry. Indexed allocation, thereby you can see it supports direct access. Just to illustrate the same, so we only have the index block address. So the index block in this example is block number 19. This block number 19 is indeed going to contain a list of block addresses of that file. So as I told you, the first one will be the first block. So I have my first block that is at block number 9, and I have the second block at block number 16. I have the third file block at block number 1. So here the index of the block will be the file block number as well. First block will be the first entry, second block will be the second entry, third block will be the third entry, so on and so forth. So we are putting all of it at one location. Now discussing about the advantages and disadvantages associated to the index allocation. As said, and you can see, so the direct access which was not possible with the linked allocation is possible here. Like the previous method, I need not traverse. If I am interested in a particular block of the file, I can directly access that particular block, and because it is again scattered all over, the blocks are scattered all over the disk, there is no external fragmentation. But the disadvantages is it is quite complex, and the pointer overhead here is much more than compared to the linked allocation. Linked allocation used a simple implementation of your linked list, but this requires much more than that. And if the block size is small, if it cannot allocate more number of entries, then probably we have to extend. This is one of the major issues that we have. Now if the block is too small, where you cannot accommodate too many entries, then we shall be using one of these schemes. We can resolve this issue using linked scheme or multi-level index or combined scheme. Let me take one by one. The first one is the linked scheme. So in this scheme, what happens? If two or more index blocks together for holding the pointers, every index block would then contain a pointer or address to the next index block. So to allow a very large file or too many entries of the index block, we link it with several blocks. For example, if an index block might have some 100 disk block addresses, the next address, that is the 101st address, would be a link to the next index block. So here we use multiple index blocks to have the pointers to the file. The next scheme that we have is multi-level index. So this is similar to the paging mechanism that we saw. So the first level of the index block is used to point to the second level of the index block, which in turn is going to point to the disk block occupied by the file. This method can be extended to 3 or more levels depending upon the size of the file. The file size is too large, probably the number of levels also increases. The next method that we have is the combined scheme. So here in the combined scheme, we use a special block, that is the inode block. So this inode is the information node that contains the information of the file, like the name, size, the author, the timestamp, and so. After this inode, the remaining space shall be used for the disk block address. You can see here. So we have something called as the direct block. So the first few entries or the first few pointers of the inode points to the direct block. That is, the pointer contains the address of the disk block that contain the data of the file. That is, they contain the address block of the small files. That is, if the file size is very small and it does not need another level, so it will be a part of the direct block. The next few entries, you can see it is the indirect block, and here the indirect block may be single indirect, double indirect, and triple indirect. Single indirect is the disk block that does not contain the file data but the disk address of the block that contains the file block. And similarly, in double indirect, it also do not contain the file data, but the disk address of the block that contains the disk address of the file data. So you can see here it is going at, here it is directly you get the data. Here it is taking to a block which has the address and then to the data. When it is double indirect, address and again address and then data. So it is a combined scheme of your directory structure and your multi-level. So you can see here in indirect, it nothing but is similar to your multi-level. So we have discussed about all three allocation methods. Now let us see which of the allocation method has the better performance. Taking it one by one, we decide the performance by the time. So whichever allocation method is able to retrieve the data at a lesser time, we call that allocation to be the best. Now talking about the contiguous allocation, this requires only one access to get the disk block. Since we can easily keep the initial address of the file in memory, and we can calculate immediately the disk address of the ith block and read it directly. Now in case of linked allocation, we also have to keep the address of the next block in the memory, and we cannot be reading it directly as well. So in that case, linked allocation is good for sequential access and not for direct access. If an application is more on direct access, it is better to use contiguous rather than linked allocation. And indexed allocation, we have already discussed to the end that it is very complex to be implemented. If the index block is already in the memory, then the access can be direct. But however, we have seen if the file size is too large, the index block can also span to have multiple index blocks. So having all that in the main memory is occupying too much of main memory. So this is about your performance of the three allocation methods that we discussed. The next and the last topic we have in your file system is the free space management. So here we will be addressing to why we should manage this free space, what are the techniques that are used to do the same. So what is free space management? There would be some space that is created after deleting the files, which can actually be reused. The other important aspect of disk management, that is your hard disk management, is to keep track of this free space in the memory. The system keeps track of the free disk blocks for allocating space to a file when they are created. Also, to reuse the space released from the deleting of files. This is when free space management becomes very crucial. The system maintains a free space list. So what is a free space list? It is a list which keeps tracks of the free space in the memory. So whenever we create a new file, it searches in the free space list for the required amount of space and then allocate that space to the new file. And this space is then removed from the free space list because it is no more free, it is allocated to that new file. And again, when the file is deleted, its space is added to the free space list. So when a new file is created, there is a removal that happens from the free space list of the amount of memory that is allocated, and when there is a deletion of the file that is happening, so that amount of space shall be added to the free space list. Now, what are the ways that we could implement and manage this free space list is shown here. We have 4 techniques, that is bit vector, linked list, grouping and counting. We will see each one of it in detail. The first one is your bit map, or we also call it a bit vector. Here it is actually a series of or a collection of bits which responds to the disk block. So every bit represents the disk block in the disk, and we use the bit values to represent whether it is free or occupied. So if the bit indicates 0, it indicates that it is free. If it is 1, it indicates that it is occupied. So the bit vector or map in which each bit represents the disk block. So calculation of the block number will come later. You can just take a look of this example. So here this is my hard disk and these are the blocks. So I have 16 blocks. I am representing it with 16 bits. So if it is a 0, it is free. If it is a 1, it is occupied. So you can see here we have 0, 0, 0, 0, 1 and then 1, 1, 1 and again 0, 0, 0. So here, so this bits are, each bit is representing a block here, and then each of it is representing the value of this bit is representing whether it is being occupied or whether it is free. So the advantages is, yes, it is simple to understand and it is very easily and we can efficiently find a free block. So when I am just scanning through these bits, so when I find a non-zero, it indicates that it is occupied. If I am finding a 0, it indicates that it is free. So by just scanning these bits, I am able to identify which are the free blocks that are available. Now calculating this block number, So this is the formula that is used to calculate the block number. That is, if I just, for the same example, if I just consider the first 8 bits or a group of 8 bits, so number of bits per word I'm using is 8, and then the number of 0 valued words, it is given as a 0, and then the first offset, that is first when I'm going to find a 1, the offset of the value 1 is at the 5th level. So that is what is the offset of the first 1 bit. So it is at the 5th level. So calculating that is where I will be getting my first free block number. The next thing that I have is about the linked list. So this technique, we have already seen it in your previous allocation method as well, but here it is a little reverse. There in the allocation method, we had a linked list for the allocated blocks or the file. Here we are having a linked list for the free blocks. So here the linked list is used to keep track of all the free blocks, and it is going to traverse from one block to another. So all the free blocks are linked together. So each block contains a pointer to the next block. The block number of the very first disk block is stored in a separate location on the disk. Sometimes it can also be in the cache memory. Now let us see a small representation of the same. So this is your linked list of free space management. So you can notice here, so the very first block, that is the block number 5, which is free, that is maintained in the separate location. That is, the head of the list is maintained in the separate location, and then it is going to point from block to block. 5, 6, 7, 14 and then 15. The last block would also contain a null pointer, which indicates that that is the end of the list. And we have already seen the disadvantages previously also. So again here the major, like just we have seen previously, the major drawback here is the pointer and the traversal. So if we miss out any link, or if there is a corrupted block, probably there will be high chances that we miss out all the blocks that lies ahead. And the other thing is to traversal through the list. The next technique that we have is grouping. So grouping is a variation to the linked list. So here what happens is, it stores the addresses of n free blocks in the first free block. Now here, out of these n blocks, the first n minus 1 blocks are actually free. The last block would contain the address of another n free blocks. This is quite simple to implement, and it is an easy approach. Rather than having a pointer, so the addresses of all the free blocks is stored in a single block. And the other advantage that we could have with this technique is, at a single access we may get a list, or the group of addresses of the free blocks can be easily retrieved. The next and the last technique that we have is counting. So counting takes the advantage of the contiguous allocation. So this technique would be very helpful for the contiguous allocation. So in this approach, it stores the address of the first free disk blocks and the number of free contiguous disk blocks that follow the first block. This technique is very similar to the contiguous allocation. There we are allocating, here we are looking for the free blocks. So it keeps tracks of the first free block and the number of blocks that is free after that. So when there are multiple contiguous blocks of free space, then the system can track the starting address of the group and the number of contiguous blocks. And this technique can be easily used by the contiguous allocation. So this completes your free space management and also your file system and also your module 4. So we have discussed about the file system, its implementation, various techniques, the advantages, disadvantages, and various support for the file system on the disk, in the memory, and the various tables that is maintained. Thank you, students.